Right, so you should have by now covered this topic numerous times in both physics and in chemistry. It's one of those topics that overlaps, you know, both of those branches of science. But obviously I'm going to talk to you about it in terms of physics. So first of all, a reminder what our current model of the atom looks like. So we've got the nucleus, and along the outside we have the electrons. This is called the nuclear model, or the Bohr model. Okay, because there were previous models of the atom which we will look at in another video when we talk about Rutherford's scattering experiment. But for now, this is the most up-to-date model that we have, the one that seems to fit with the evidence. Okay, so this is obviously not drawn to scale. The nucleus relative to, you know, the size of the whole atom is nowhere near as big as that. It's more, I think it's something like a pea in the middle of a football field. That would be more proportionally correct. And obviously they're very tiny in reality. So the electrons orbit around the outside of the nucleus, and inside the nucleus there are two nucleons, which means nucleus particles, and they are protons and neutrons. Here we go, there are the electrons. They are negatively charged. This means negative charge. Protons are positively charged. Neutrons, zero charge. In addition to that, other information you need is the relative mass number. So you have a proton, the relative mass. I don't think I've left myself enough space to do this. Relative mass is 1. For neutrons, relative mass is also 1. Okay, so i.e. they're about, remember the word relative means like compared to something else. So the proton compared to the neutron, well, if they're both 1, then they're about the same size. And electrons, relative mass, it's very small. Some teachers I've heard say that it's close to or approximately 0. I mean, technically no, it's just, I mean, it is very small, of course, so it's closer to 0 than a proton or neutron, but it does have a value. I believe it's 1 over, I might need to check that. I get mixed up between 1 over 2,000 and 1 over 8,000. I think it's 1 over 2,000, but I'll check anyway. If it's wrong, then I'll put a little note with this video to say that it's what the actual value is. So those are the relative masses. And I've talked about it, you know, so I've said positive charge, 0 charge, and negative charge. However, the actual, what we call the relative charge of all of them are, I'll put this one up here because I've run out of space. Relative charge for a proton is +1. Relative charge for a neutron, well, I've actually kind of said it already. Relative charge equals 0, and for an electron, relative charge is -1. Again, remembering the word relative means compared to something else. So, you know, the actual charge on an electron is, oh my goodness, 1.69 times 10 to the minus, oh, I've actually forgotten the charge. That's really embarrassing. I've forgotten the charge on an electron. It'll come back to me in a minute. But the proton has the same magnitude of charge, but it's positive as opposed to negative. I can't believe I've forgotten the charge on an electron. It's been that long. Anyway, so that's kind of what you need to know about the atomic structure. Remember, most of an atom is actually empty space. So all of this bit in here, that's all empty space. In fact, there's that fact of if you were to take out all the empty space in the atoms of, you know, all of the human race, then the whole human race would be able to fit into the size of a sugar cube. So that really shows how much empty space there is in between, in between the nucleus and the electrons of the atoms in our bodies. You know, some people have more empty space than others, but yeah, I know that's a bad joke. Anyway, so we've done atomic structure. Is there anything else I want to talk about with that right now? Yes, there is actually. Talking about electrons around the outside. So on the first shell, you can fit a total of 2 electrons. The second shell will be 8 electrons, and the third shell will be 8 electrons. You wouldn't find 1 electron on the first shell and then 5 on the next one, okay? It will fill up the shells before there's a new shell. So it would be 2 on the first one, and then there could be 5 on the next one. It would be incomplete, the outer shell, but that is possible. That kind of determines how reactive it is. That's why you find in the periodic table all of the atoms in group 1. That tells you that there's 1 electron on the outer shell. So they're often very, very reactive. And group 7 as well. If you're in group 7, you've got 7 electrons on your outer shell. That means there's space for 1 more. And if you only require 1 more, that's going to make it more reactive. It's more likely that an element from group 1 is going to react with an element from group 7, because that way you're filling both shells. You're filling, yeah, everyone's happy. Okay, I think I'll leave it at that for this particular video, and then I'll go on to a new video to talk about atomic mass, atomic number, and isotopes.